Hello everyone, very good afternoon to all of you. Now we are starting this session. Dear authors and invited guests, I'm Prarthana Joshi, the moderator of this session. On behalf of Global Knowledge Research Foundation and Knowledge Chamber of Commerce and Industry, it is my great pleasure to welcome you to the 7th International Conference on Information and Communication Technology for Sustainable Development through Zoom. I hope you all will enjoy the knowledgeable and interactive sessions through the day. There is a special note for all the presenters. You will be given 7 to 8 minutes for your presentation and further 2 minutes for your question and answers. I will raise a gentle reminder on 7 minutes. So please stay connected with us until the closing remarks. Just before we get started, I would like to introduce you all to the chair of our session, Professor Swati Nikam. Welcome, ma'am, to this session.
Thank you. Thank you, Prarthana.
Yes, Professor Swati Nikam has total 19 years of teaching experience in computer engineering. She is working as an associate professor in the Department of Computer Engineering in Dr. D.Y. Patil Institute of Technology, Pimpri from 2001. Her research areas are cyber physical system, information security, Internet of Things. She has also published more than 40 plus research papers in reputed international journals and conferences. She has also attended more than 50 plus seminars, conferences, and workshops. It is our pleasure to have you here, ma'am. Now, I would like to call our first presenter, to present her paper on a study on medical image data augmentation using learning techniques. Dear presenter, please start your presentation.
Good morning, madam. Am I audible? Hello?
Yes,
Okay.
you are audible.
So, in 1 minute, I will share my presentation. Is it visible, madam?
Yes, ma'am. Please go ahead.
Okay. Good morning, one and all. I am Vanita Jadhav. I am a research scholar at the Department of Computer Engineering, Srimati Kaushibai Knowledge College of Engineering, Pune. I am doing PhD under the guidance of Dr. Lalit Patil sir. And my topic is for this presentation is a study on medical image data augmentation using learning techniques. Outline of my paper is introduction, motivation, literature survey, objective, conclusion, and references. Introduction. So one major disadvantage of computer assisted detection system is the massive quantity of data needed to train them, which is costly in the medical industry. A big training data set is critical in deep learning since it enhances training accuracy. If we provide the big data set having big size, so deep learning models, they are giving more accuracy, especially in case of medical field. The term data augmentation states a group of approaches for increasing the volume and quality of training data sets. So basically data augmentation we are using just to increase the size of data set, that is volume, and quality of training data set. In discriminative challenges, deep learning representations have achieved unbelievable growth. So especially in my research, I'm going to take the help of deep learning networks, I'm using the data augmentation technique to increase the size of the standard data set, and the major objective is to prepare the live data set with the help of standard data set by applying the data augmentation techniques. Convolutional neural network success has raised interest in using deep learning to solve computer vision issues. The validation error must decrease with the training error in order to figure out effective deep learning prototypes. Data augmentation is a very effective way to accomplish this. In this study, we conducted a comprehensive study of the literature in which data augmentation was used to train a deep learning model using lung CT images. So basically, my research is based on the lung CT images. So I just want to take the input as a lung CT images. If you consider the medical field, so we are unable to get the huge amount of data. We are getting actual very less amount of data, very less images. So if we increase, if we want to achieve the accuracy, so we need to take the help of augmentation methods so that we can increase the size of data set. So my main objective of this study is to prepare live data set representing CT scan images along with standard data set and data augmentation methods. In the sense, so I use the data set ILD, LIDC, which are related to the lung CT images, and I'm going to apply the data augmentation methods on these data sets. Again, the size of these data sets is very limited. I want to increase the size of these data sets. So this is my main objective, one of the objective from my research. Motivation behind doing this paper, that is a big training data set is critical in deep learning since it enhances training accuracy. So majorly to increase the accuracy, I use this method. Even with a big amount of data, a weak algorithm can be more accurate than a strong algorithm with a little amount of data. In the sense,
Anita, sorry to disturb you, but your slides are not moving.
okay, madam. Just a minute. Is it visible, madam, now?
Yes, it's visible now.
Okay. So this is the motivation behind my research. The basic motivation is nothing but to increase the data set size to get the accuracy, training accuracy. I had done the literature survey. So whatever methods are present in existing study, so I have just listed all these methods. Basically, these methods are categorized in two categories. One is basic and deep learning data augmentation techniques. So which I have shown over here. So these are all the methods. Two categories, two major categories are the data augmentation based on basic image manipulations, and second one, data augmentations based on deep learning. So under data augmentations based on basic image manipulations, so I studied geometric transformations. Under geometric transformation, I studied flipping, color space, transformation, cropping, rotation, translation, and noise injection. Then under kernel filter, so basically this method is used to improve and shape the images. In random erasing, it is related to dropout regularization. This method was developed to overcome occlusion related image identification challenges. Regarding color space transformation, picture data is divided in three matrices which has a different size. Matrices signify the pixel values for each RGB color. So red, green, and blue color. So basically, the drawback of color space transformation is it requires bigger memory. Also, cost of transformation is somewhat high, and time required for training is more. Then mixing images. So in mixing images, images are mixed. Images are combined. So this is about data augmentations based on basic image manipulation. And second one, data augmentations based on deep learning, which I am going to use for my study, for my research. So under that, adversarial training is there. This is a method of using two or more than two networks with loss functions that have contrasting purposes set in them. This is about adversarial training. Then neural style transfer. Fundamental impression is to use CNN generated image representations. So convolutional neural network generated image representations we are using under neural style transfer. Then GAN based data augmentation, the exercise of constructing artificial instances from a data set with parallel feature to the unique set is known as generative modeling. So we are taking the help of generative modeling in case of GAN-based data augmentation. And the last one is the meta learning. So meta learning consists of neural augmentation, auto augmentation, and smart augmentation. So different methods are there under meta learning. So actually these are the methods which I thoroughly studied just to implement my objective, and the objective is to prepare a live data set with the help of data augmentation techniques and standard data set. To prepare live data set representing CT scan images along with standard data set and data augmentation methods. So just to summarize the work, whatever I done, so I studied different standard data sets like LIDC, CIA, Luna 16, JSRT data set obtained from UCI repository, Kaggle, GitHub, etc. And actually, I studied all these data sets. So some of the data sets, they are working on X-ray images and some are working on CT scan images. So basically LIDC, it is related to CT scan images, and that's why I choose the standard data set LIDC. And on that, from that LIDC, so the images, I downloaded this data set and I performed the data augmentation technique with the help of flip left, flip right, flip up down image transport operations, and I prepared the big data set. So this is the summary of my work. These are the sample cities images from LID's data set. If you are observing, so two different images are there. In the first image, I am able to see the nodule, which is a big nodule, and in the second one, very small nodule is there. So maybe it may not be cancerous, but in the first, it is the majorly it is cancerous. So basically, my research is related to the lung cancer detection, and for that purpose, my first objective is preparation of the live data set. And that related to this, I presented this paper. So this is the conclusion, that is just to increase the size of data set, I taken the help of this method and I implemented this. These are the references, some of the references which I used. Thank you. Hello, am I audible?
Yes, you are audible.
Okay, thank you.
Yeah. Thank you, Vanita. Thank you for the presentation. I have one question. Like,
Okay.
you have done this research on data augmentation, right?
Yes.
So just tell me, I mean, just summarize the gap which you have found.
Gap basically in the existing systems, they use the standard data set, and mostly in case of medical images, the size of data set may be very small. No standard data set is having that much big amount of data, big amount of set, and basically related to deep learning, to train the network, we require the big data. And that is nothing but the basic purpose behind this research.
Okay. And what would be the proposed solution for that?
Proposed
Solution, proposed technique.
I have done the implementation, madam. I have taken LIDC data set, almost 108 patient images I taken, CT scan images, and I achieved the result almost 4,000 images.
Okay. Yeah, thank you, Anita.
Okay.
Thank you so much, dear author. Now we are moving forward to our next presentation. I would like to call next presenter to present his paper on premise or cloud computing, an integrated novel approach to study the adoption of software products deployment model with different scopes.
Hello, good afternoon, everyone. This is Hashmat. I will quickly share my screen. So I hope you can see it.
Yes, sir.
Okay. So good afternoon all, respected session chair, Dr. Swati. Basically, I am doing my research on adoption of enterprise software product deployment model in ICT4SD University, Jharkhand, under the guidance of Dr. Rajkumar M. So basically, the agenda is similar. I mean, first I will introduce my problem, and then what is the objective, and then followed by the methodology, and then a little bit discussion, and then conclusion. So let me start with the introduction. What is the problem I'm working on? So traditionally, software products were available to customers or to the organizations in on-premise deployment model. Okay, so that means you will get a CD with a license key. So you need to install that particular software on an appliance or on a VM, so to make it operational or functional. Now, if you take up now, if you consider today's recent emergence of various technological platforms, right, in cloud computing, you have software as a service, you have infrastructure as a service, you have platform as a service, and you have again much more services available in the cloud. So with this innovation, now organizations or customers, they basically have two kind of deployment models. One is on-premise, the other is cloud computing. So which one to adopt is the actually challenge for the organizations. So little more about cloud services software. So it basically on a broad level, if you talk about, so there are a lot of innovations happening in cloud side basically. So, but the broad level is that software as a service. So we, in our day-to-day life, in our offices or we are using basically Google email, or we might be using Microsoft Office 365. So these are the examples of software as a service, cloud service. When you talk about platform as a service, then you have platform is nothing but a operating system. So the example is Windows or Linux. And then infrastructure as a service, it is basically nothing but the vendor will be virtualizing the hardware infrastructure like storage or networking hardware, RAM and all. That is the example of infrastructure as a service. So with these two kind of deployment models, one is on-premise, the other is your cloud deployment. So organizations are basically posed with a challenge, which one to adopt, which one you should go for actually. So that is the basic problem for any organization. So this research study basically, is going to consider three scientific models. One is technology, organization, and environmental framework. The second is diffusion of innovation. The third is DMetal. I will give a quick brief introduction of each scientific model, what each one will do, and how it is going to help in studying the adoption behavior of organizations. So TOE model, TOE framework is basically for organizations. You might have different scientific models also, but for organizational perspective, this is the main, from the literature review, we have found that this is the main framework which all researchers are following. So basically, it actually comprises of three contexts. One is technology context, which talks about the technical features of innovation. Basically, you have a product and you want to adopt it, and what are the technical features which are going to influence your adoption behavior. Organizational context is nothing but the demographic variables of organization, like how old it is, how many people are working in that, and are they ready for adoption of these technologies or this innovation. Environmental context is nothing but it's like basically the environment in which an organization is operating. So there are several factors which affects here. So like your business partner pressure or the type of industry. So for example, government organization may not adopt cloud technologies, or there is a data retention law from Government of India that the organizations like credit card organizations, they should not store KYC documents in the data centers which are outside of India, right? So most of the cloud vendors, they store their data in Singapore basically. So India doesn't have any data center. So Indian government has bypassed the rule that you should not store our KYC documents outside the Indian territory. So those are the environmental context factors. So this is one more theoretical framework, scientific model, diffusion of innovation, which states that an idea, basically, if any organization wants to adopt, how it is communicated and how it over a period of time. So there are different stages a organization might travel for adoption, and based on that, there will be different factors actually. So the last one is DMATL, which helps in studying migration. So you already adopted an innovation and you want to migrate to a new innovation. So this is the framework which is going to help, and it will tell you it is based on cause and effect. Basically, if you have adopted an innovation, so now there is a new model in the market. So what are the benefits which it is providing, and what are the risk which it has? If those benefits bypasses the risk, then only you are going to adopt it. So what are the benefit factors? What are the risk factors? This theory is going to basically help us. So basically the objective is to identify, this is the uniqueness, this is the newness, which we are going to basically introduce in our research study. So to identify the different scopes, basically, in which an organization is, to identify that scope, and how these scientific models are going to help, because for each scope, the factors will be different. Okay, so research methodology, as I said, basically we are going to integrate these three scientific models to find out factors based on each scope. So conceptual model is again same. We are going to integrate these three frameworks and we are going to identify the factors. So scope one is basically an organization, right? It has a new requirement, and for example, I'm going to start my organization today. So I have two deployment models. One is on-premise, the other is cloud computing. For if I want to buy a email services, like I have Exchange Server, which is on-premise, I have Office 365, both from Microsoft, right? So what is that? So this is that scope, the scope one. I have new requirement and I have a challenge, basically, which one I should adopt. So these are the factors which is going to lead to my satisfaction, and then based on my satisfaction, I will adopt the appropriate model, whether on-premise or cloud. Scope 2 is basically for the organizations which are 5 years old or 10 years old, right? They already adopted on-premise model, because those days cloud technologies were not available. Basically now, now cloud technologies are emerging, and you have cloud deployment for each technology. Now organizations in this scope, in this stage, who already adopted, now they want to migrate. So what is the cost of migration, and how, based on their satisfaction, how the perceived benefit factors are going to surpass the perceived risk factors, and what are all the other factors which will influence. Based on that, they are going to take a decision whether they should adopt cloud model or they should not adopt it. Now the third scope, there are certain organizations, right, who are known as, according to diffusion of innovations, they are known as early adopters. Actually, when the innovation comes into the market, they will be the first one to adopt it. But later on, they will realize this was not the correct technology or correct innovation for our needs, for our organization, because we are high in them, we are more in numbers, we have budget problem. The old traditional software deployment model was working correctly. So now they want to migrate back to the original one. So this is the scope which is going to, because they got dissatisfied here actually with the adoption of cloud. Now they are going to again migrate back to on-premise model. So this is all about the different scopes. So the conclusion is we basically found that there are a lot of research going on in this area, and a lot of people are already doing, but when they talk about just adoption of cloud. So they don't really understand how a decision goes in an organization, because buying process for an individual is different and for an organization is different. Organization may be in a different stage and they might fall into a different scope. And again, there are different stakeholders also in the buying process. It is not just one person who is going to decide it. So if you take any paper or any work which is available on the internet, so they don't consider all this. They just talk about adoption of cloud. They don't consider that there is on-premise also. Banks or defense organization or government organization, they won't go for cloud technologies. So that is the reason. So this is the one newness in this in this research work. So the most common scope, what we found from our pilot study, is basically nothing but organizations are already adopted on-premise version of software product. They now want to migrate. Actually, this is the most common which we have found. So this will be the center of study. And the last one is we have to actually find the factors which will influence depending upon the different scope. Each scope will have different factors actually. Migration factors will be different than the adoption factors. So this is all about it. References, and thank you. I'm done. Hello. Hello.
Hello. Yes, Ashmat. One question I want to ask is, you have mentioned about these factors, some factors.
Yes, madam.
I mean, prominently, which all factors you are considering under each category? Because there would be a number of factors. So.
Correct. Yes. So factors basically, if you talk, right. So I told, right. So there are, after integration, we get, so there are different people who are actually involved in the decision process. One is technical person. The technical person will see only technical features, right? For example, IT team or IT manager, he will be interested only in technical features of the product. So those technical features are nothing but a relative advantage. Do I have advantage in adopting cloud, or do I have advantage in adopting on-premise? When you compare both of them, the cloud is more robust because the latest features are basically available in cloud deployments. So they do monthly upgrades. Thereby they support latest. But when you talk about on-premise, these releases will happen on a quarterly basis or half-yearly basis. So customers or organizations, they have to wait for those technical features. So that is where the on-premise is lagging. And when you, these are the, actually I am highlighting, these are the factors when you talk about the factors. And again, when you talk about migration scope, then the factors will be different actually. So it will be this one. If you want to migrate to cloud, now you have in cloud, you have option to pay on a monthly basis, which is not there in on-premise. On-premise license renewal will happen on annual basis. And cloud is basically, if you are using something, then pay for it. In on-premise, you need to pay for entire features, whether you are using it or not. And it is easy to deploy, right? And latest functionality is always available, but there is a risk involved. If you are a defense organization or if you are a government organization, the risk factor will be government has data retention law, that is data locality, right? Government of India already has data locality. They just, I mean, just couple of months back, they announced that. And then how secure is my data in cloud servers? Because my data will be stored in the cloud servers, which is controlled by either the vendor, who is the vendor. So basically it will be Microsoft or Google. So what is the security? What is the privacy of my data? So these are all different risk factors. Then again, I have few more adoption factors like relative advantage, how complex it is, whether using on-premise will be complex or using cloud will be complex, or are they compatible? So observability and trialability. I want to try out that particular software. So how much are you really supporting the trial versions or not? So what is the support? So those are all different factors basically.
Okay, thank you, Ashmat.
Yeah, thank you.
Thank you so much, dear author. Now let's move forward to the next presentation. Can you please stop sharing the screen?
I don't get that option. I am seeing resume share and okay. I believe resume sharing, pause share. I don't have. Oh, I got it. Now I stopped it. Yeah.
Okay. So I would like to call our next presenter to present his paper on design of efficient energy management solution for the Internet of Things based smart microgrid.
Good afternoon to all.
Good afternoon, sir.
Is it visible now?
Yes, sir.
Thank you, ma'am. Good afternoon to all once again. I would like to thank the organizer being effective in conduction of this event. The topic of my is design of efficient energy management solution for the IoT based smart grid. So now the energy management system for microgrid with supporting of smart is a trending topic, as we are in Indian and then state government, central government are concentrating the realizing the energy management with various of sources, particularly green energy, windmill, solar energy, power grid. Using the power grid, we have going to the commercial as well as home-based application for both on-grid and off-grid applications. So now they can today some literature survey taken from the literature survey for various of loaders with having a dynamic supporting. So that we have to use separate the two users, commercial as well as home-based using. So here we have smart grid for micro-based applications. The client will be taken of utilizing the energy with effective manner. So we are trying to give them energy management solution for government side to allocating the power systems based on the users. So for the demand of the commercial users as well as the home-based applications, it will be allocated the timing based for night shift to day shift for particular industrial applications and medical-based emergency applications. Likewise, we have to splitting the schedule and we have to reduce the congestion as well as the power disconnect. So then we have to find out the energy gap, the energy management solution with research gap that we can globally we have to raise that energy requirement utilization is very important thing. So most of the countries are following that postpaid prepaid in state government of Tamil Nadu. They are using the postpaid only. They are trying to go for prepaid systems. There we have to necessary to do some energy management solution for the particular problems. So here we have to divide that. We can do solutions. First one is energy efficient solution, another one is energy harvesting solution. So we have to collect that energy harvesting from various of sources, green energy sources. At the time, we have to give some basic utilization to develop the energy to provide the power environment in effective manner. So we have designed a system. First of all, we can getting a power generator and PGM system that we can go for generating, and we have to create the power voltage management to provide that IoT based systems. So here the cloud approaches and then scheduled optimization and energy consumption will be calculated to the EMS, that is energy management solution, in that EES, that is energy efficient solutions. So here we have to connect it to the power management of current as well as voltage calculation, the particular values. Then we have to make it as power management generation based on any green energy, windmill of like that, and PV will be taken as a solar energy systems. So that we can make it as 1 kilowatt to 2 kilowatt for the minimum, the maximum for 10 kilowatt we have to generate. As per the Indian standard, we are taking a 230 to 40 volt to 50 heads up. In that single battery voltage, we 24 volt, we are concentrating for smart micro gate to design these systems. Because of they record the 48 and 60 volts that we cannot be maintaining the current rating to the off-grid as well as on-grid. So on-grid will be continuing the minimum amount of 13 amps in Tamil Nadu state government. We are maintaining the 13 amps, so we can maintaining that both the current and voltage. Then we have to make it as system like this. So this is a solution. We have developed the two systems. One is cloud-based, IoT-based energy management optimization and energy consumption. And then we have to make it as harvesting. Solar as well as wind will be harvesting for microgrid. Making energy routing is a very important thing. We are concentrating on both two structures. So this is my objective. We developing the rapid urbanization to the energy transport and environmental life quality will be increased in sustainability areas based on IoT and cloud approaches. That smart application changes the digital world to giving an advanced web device interfaces. So here we have to making a metering infrastructure power to the grid to enhancement. Net metering are offered by both state and central government. Now that state government has released a lot of opportunity to provide that up to 10 kilowatt to the home-based users. So they can claim the 40% of cost will be subsidy from the government side. We can generate the 10 kilowatt minimum of structure will be developed in the existing remote systems. We have to develop in the remote area that we cannot be generate the power to the grid wise. So here we can easily we have to provide that IoT systems that we have a continuation solutions. So this is a proposed IoT based smart time. We have to generating the protocols here. So the linear operation economics given the control of the energy management framework using the IoT. There is a two divided on a scheduling interface with your cost, and then you have to give the assignment to the particular programming. So here we have to making a framework to the automation of the systems. So that can generating the user-based allocation. We have to develop this result with the simulation using the MATLAB. The first one will be generating the power generation. We have to monitor the IoT based with smart gridding. So we have to take the power calculations from the time-based systems. So based on that energy, you have for two, one is wind, one is solar. The solar energy will be collected from the sun intensity, that particularly morning 7 to evening up to 5 o'clock in Tamil Nadu region. We analyzing the geographical region in Tamil Nadu, at particularly Chennai. Then we have to make it as 1 year of data. We will collect that 365 days to the every seasons, divided into 4 seasons, and then we have to make it as calculating load pattern of the electricity traffic. We are analyzing the two different parts. One is industrial part, another one is home-based application parts. That also we will find out the traffic and then loads. Then we have to separate the three energy transaction using EMS, that we have to make crowd power and then load and then smart grid power. So that will be optimized using the our systems. That system will be optimized that we have to maintain in the energy harvesting as well as energy generating. So we achieved that in this paper. So the giver classified two different solutions, and we are giving the directions to the access the energy efficient solution for both the EMS but IoT based. In this study, we will calculating the cost wise that we investing cost is high compared to the economic of home based application like 1 kilowatt, 2 kilowatt. But those who are having that more than 500 unit of energy in the Tamil Nadu, we will provide that effective cost solution for the particular users. So future we can make it a simulation for the overall postpaid, prepaid customers, as well as we have developed in the area wise. We have to divide the area wise, and also we are giving a system that we can analyzing the solar as well as windmill. So that windmill will be analyzing the using the data science application. We are developing the calculating of rotation of the fan as well as the time period, and we are getting analyzing. We are predicting the season as well as airflow in the based on the green energy as a windmill. In solar side, we are also same thing. We have to realizing a performance analyzer. We are using the IoT with the supporting of data science. We are creating the 365 days of data from every half an hour. We are taking 48 readings of per day, including moonlight. So we are developing that particular smart system solar cell. But in night side, we didn't have any improvement of our approaches, but we are getting that different angle in industrial side. These are some selected reference we are collecting for later our work. Thank you.
Yes, thank you, sir, for your presentation. I have one question. Like now, you have shown some simulation results.
Yes, ma'am.
So, is it validated with practical results and some implementation?
Yes, ma'am. We are developed IoT based analyzer kit. So there we can giving a 10 to 15% of error from the simulation. We have 10 to 15% of error we occurred. Based on that simulation, we are correcting the partner. Yes, ma'am. Are you able to hear me? We have done a harder part also, ma'am. but it is getting a 10 to 15% of error compared to the simulation. Hello.
Yes, sir. Yeah, thank you.
Thank you.
Thank you, sir.
Thank you so much, dear presenter. So now next, let's move further with our next presentation, and it will be presented by A. Kavitha, and her paper title is called, sorry.
Ma'am, sir, good afternoon.
Yes, yes.
Is it audible, ma'am?
Yes, yes. Please continue.
1 minute, ma'am, I will share. Ma'am, is it visible, ma'am?
Yes.
Yes.
Yes, ma'am. So good afternoon to one and all present on the meeting. My title is it audible, ma'am?
Yes.
Yes.
Yes. Myself, Dr. Kavitha from M. Kumarasamy College of Engineering, Karur. My title is Fall Detection Using YOLO for Elderly. Actually, nowadays, taking care of elderly is a big process, and it is in need of very patience. For that purpose, we have developed a hardware project as well as product, as well as we have done a software project. That is this one. That is a fall detection of elderly using YOLO detection. It is deep learning algorithm. By using this, we have to monitor the elderly people. The objective of my paper is to assist elderly to live independently. So it is not possible all the time to monitor them. Even we have provide some support like monitoring or caretaker. So for that purpose, we have developed this. And then another objective is to render immediate assistance to the elderly during any illness or accidental incidents. Suppose any problem occurs, we can easily monitor them through mail or message. So and then we can provide the immediate support. Even though we are providing some take care, if suppose they are in sleep, then it's not possible to monitor them. So for that purpose only, we have started this project. This objective was done in this paper with the help of deep learning algorithm, that is a YOLO algorithm, YOLO detection algorithm. Next slide. Actually, for this proposed system, the data set for our project is collected from the third-party website called Google. Each two classes contains 150 images. For this purpose, we have taken the 150 images. Here we have taken the label MG is an image labeling tool, which is used in the proposed method. Here we have used the DarkNet framework help to train the model with the help of DarkNet 50 network. And then we train the system, and then train model has been applied in the deployment process. For capturing the image, we have used the web camera. So webcam capture is directly applied to the deployed model. The deployed model is in the process or the video frame by frame. Actually, video is taking when the person is inside the room, there will be a video. The video is capturing for every second to second, the video is taken, and it is converted to frame by frame. So after, if the frame is any change in the frame, then automatically it will be identified. Next slide. Actually, here we use the YOLO version 3. It uses 45 frames per second from the videos, and each and every frame scanned by the YOLO algorithm and detect whether there is any human falling is there in the frame. Next. Actually, this is our block diagram. So the data collection, and it is set by the train model image labeling. And by using the YOLO algorithm, the trained file is detected by using the current file. If suppose the video is converted into frame by frame, so after that, if any detection is found, then it will be indicated through mail or message. Next. Actually, it is algorithm. It is one of the deep learning algorithm. So here it is YOLO is the abbreviation of you only look once. This is an algorithm that detects and recognizes various objects in a picture. Normally, we are training the system using one type of method. So if suppose anything is different, then it will be detects. Actually, this algorithm is used in the real time pictures, and it is an object detection in YOLO. It is done as a recurrent problem and provide the class probabilities of the detected images. This YOLO algorithm employs convolutional neural networks to detect the objects in the real time. As the name suggests, that the algorithm requires only a single forward propagation through a neural network to detect the objects. This means that the prediction of the entire image is done in a single algorithm run. The CNN is used, there's a convolutional neural network is used to predict the various probabilities and bounding boxes simultaneously. The YOLO algorithm of various variants, some of the common ones include the YOLO and YOLO version 3. Next slide. Next slide. The first in the black diagram, you have mentioned the data collection. So the data collection, there are two classes of images has been collected in the module. So one class is fall detected and another one is not fall. So we have for training the system, we have taken that 150 images. For 150 images, it is not falling, and another 150 is a detection how the detected people like that. So we have trained the system like this. So each and every class has 150 plus images, and then the second in the black diagram is image labeling. So here label IMG is an open source tool which is used in the label the image. So for every image we have given the label name. Each and every images are labeled by using this tool, and then we have given the training using the YOLO algorithm. In this module, a darknet framework and darknet 50 has been utilized in order to train the model. The overall architecture is given in the slide. So here the number of epochs we have used is 4,000. After completing the training process, the weights files will generated and stored. So after that frame conversion, so first one is we have taken the images, and then we have given the labeling the images, and after that we have trained the images. And whenever there is a video, then the frame from the video the frame will be converted. So the captured video is converted in the frames in the module. There is a frame conversion, and then fall detection. In this fall detection, the web camera is we have given in the we have taken the videos from the web camera, and the web camera is capturing the videos from this. The trained model will convert the videos into frames. So every second 45 frames will be converted. If the model detects the fall, then which will send the message and show in the output side. Next slide. Actually, it is a deep learning technology. So comparatively, it is a high accuracy for predicting the patient conditions, because we have already done one hardware project. So from this, we have compared, because we have taken as it is simulation work is in the first time. So we have taken only the YOLO algorithm. So it is high accuracy compared with the hardware method, and it supports all direction in the room. Actually, in our hardware, we have given in the one direction, but here it supports in the all direction. It supports hospitals and health centers. We can use it and process the frames of 45 frames per second to 150. We can use this for till 150 frame per second. Actually, it is a very for smaller network. We can take 45. We can take more number of frames. So it is better in the real time. Next. So this is some of the sample collected data sets. From the fall detections, we have whenever we are giving the training in the network, we have given these types of images. The detection of because from the bed they have stand up and then they maybe fall down. So these are the images we have taken for the training. So this is the output. When the patient is standing, then their height and their width will be measured, and this will be actually here we are taking the image labeling. So here this will be taken within this frame within this label. So this is the actually here it is not does not identify the fall detection. This is one type of output. Next slide. So this is output here. By using the YOLO detection algorithm, it measures the height and width. Here the patient is fall down, so here height and width is varying. From this YOLO detection box, it is measures that the elderly is fell down. Next. So in this project, the fall detection system with the mail alert has been implemented, and then here a transfer learning based training process reduce the training time of the proposed method. So this is our proposed work. Next slide. So these are my some of the references. Thank you.
Thank you, Dr. Kavita.
Thank you, ma'am.
I have one question, two
Yes,
questions rather. I mean, what is the significant difference between YOLO and YOLO 3? And
Actually, there is yes, ma'am.
please, please.
Actually, there is a version, ma'am. Actually, we have concentrated on the hardware development by using this algorithm in the visible light communication, ma'am. And we have taken the output and we have filed it as a pattern, ma'am. But here we have started this work. So that time we get the version of YOLO version 3. So exactly, I don't know the difference between YOLO and YOLO version 3. But we have easily get the YOLO version 3 in our college. That's why we have started that work. So presently it is available, ma'am.
Okay. Okay, fine. And my second question is, I mean, what challenge you faced in this implementation?
Ma'am, for training, we have taken a lot of images, ma'am. Actually, I told that it is 150 images for training, but we have taken more number of images because while labeling the images and we have given the input, it is not easily acceptable because sometimes they have fell down and they have take the leg upside. That time the height is not varied. So again, it shows that actually every time the image that is a video is converted to frame by frame, that time it doesn't identify that it has fell down. So that type of difficulties we have faced, ma'am.
And to what degree was able to predict it?
Actually, we thought it is for that is parallel to the floor is we thought it is fell down, but the system when the size is increasing, there is a height is decreasing. That time it measures it is a fall fell down sometimes, and sometimes it is not identified. So the process is going on in this work, ma'am. So actually, it is a small module work, ma'am. In the software, it is a small module. The further the process is going on, ma'am.
Okay, thank you.
Thank you, ma'am.
Thank you so much, dear presenter.
Thank you, ma'am.
Now, now let's move further to the next presentation. Will be presented by Nirali Anand Pandya. Her paper title on survey paper on multi-wire object detection challenges and techniques. Yes, ma'am. Please continue with your presentation.
So my title is Survey Paper on Multi-View Object Detection and Tracking Challenges and Techniques. So these are the outlines. Now first I want to introduce the object detection. That what is basically object detection? So object detection is a technology in the field of computer vision for finding and identifying the objects in an image or a video sequences. So sometimes for object detection, input is your image as well as the video sequences. And basically, in this paper, I am focusing some challenges. One of the major challenge for any particular object detection algorithm or model is the views of particular object. So that's why I'm focusing on the multi-view, right? So for a single instance of an object can be oriented in many different ways. So for example, a particular image of car, let's say, so having top view that is different, side, any of the side view and front view, back view, all these are different views for the car. Still, the model should recognize all that particular images of car as a car object, right? So there is a big challenge. Now, basically, what is see in this first image, what will happen? There is image, normally what is detection and what is the classification. Normally, in classification, the algorithm only or models only detect that if that particular car is there, so it will categorize that this is a car. But in multi-view detection, in object detection, normally what will happen if it is a car, then in particular image where that car present, so location of that object is equally important, and their poses. So in this particular second figure, uh, the first car having its back view and the second car having its side view. So it should detect all the poses, and it should work with all the location as of the car as well as category of the object, but that is particular car. So this made a scenario that these are the objects, but each and every object having this many viewpoints, right? So whenever the number of objects would be increased, and at that time this would be the main challenge in case for object detection algorithms, right? So styles, lighting conditions, viewpoints, all this will be changed. And here the object has that algorithm has to detect number of classes, number of views, and number of stars. So lots of challenges would be there. See, there are so many other challenges are also present, like the scalability issue, that is pose variations, then that having interclass identification, and all these are lighting conditions. Some algorithm can detect the objects in lighting. Very good, they detect in lighting condition. In that can be in whenever dark view is there, it is difficult to detect. Autonomous driving car, traffic surveillance, basic applications of any particular object detection. Normally, these are the challenges of any particular object detection. These are the applications of object detection algorithm that nowadays it will use everywhere. For example, if we take autonomous car, that in autonomous car, everything is detected by the camera. Images are captured by the camera, and that decision will be taken based on the object's position and etc. So this will be the main challenge of the in the object detection. These are the basic applications. And there are many more applications. Now let's see some data set, some standard data sets available on which these models are designed and tested. So one of them is open image dataset V6. Previously, the version V4 was available. Now, version V6 is available. So, in open image dataset V6, it contains total 16 bounding boxes for 600 object classes. So it is having total 600 object classes on 1.9 images. It is the largest existing data sets with object localization annotations. So normally, whenever we are performing any object detection task, we require actually annotations in particular format, right? So this open image dataset also allows you to customize the set of objects or set of categories of the object. For example, if we are making any application which is based on the traffic surveillance, so in that case, we only required vehicles, different vehicles. Then maybe you require traffic lights and all that. So we can also customize this data set based on our requirement. So it will be useful for that purpose also. So these are the some statistics given taken from the that official data from that site of official data set. Here we have this much images, and we have validations, train images, validation and testing images available, and total categories will be there 600. And also it also provides annotations for this particular objects, all these objects. Now, the other data sets are also available, that is Pascal work data set, COCO data set. Normally, nowadays, the models are tested or trained, pre-trained models are available, which are trained based on the using COCO data set, MS COCO data set. And the other data set is Pascal work data set. And that Pascal work data set, also, I also mentioned that thing in my paper also, that Pascal work data set having 20 object category. And the 2012 is in 2012, the last version will be Pascal work 2012 version is available. And in case of COCO data set, there are total 80 object categories are available. Okay. So now this open image, I basically I train my model using this open image data set with a few categories of object. I'll show you that result later on. So now some algorithms. Now there are some standard algorithms for object detections are available. That is RCNN, which is region based. This is the very basic algorithm. See, this is this RCNN, region based convolution neural network, which is used for detecting the object. They use convolution layer to and they use this is the first region based algorithm. Before that, some algorithm which is sliding window based and all that thing available, but that was this is the this algorithm is based on the deep neural networks. Now, second updated version of that RCNN is fast RCNN, and then after faster RCNN. The other, let's see the basic. RCNN is a region-based feature, CNN, which uses the CNN features. It's having this kind of, suppose the input image is there. The here first this algorithm first identify the region of interest, that is ROI from the proposal. And then grab the image regions and forward each region to the convolution neural network, and then after classify the region with SVM, so that is support vector machine, and it will generate the another thing, that is it will generate the bounding box regression also. So this is the basic structure of RCNN. So input is image is extract around 1,000 bottom up regions for the proposal and compress features for each proposal using large convolution and classify region using specific linear support vector machine. Now, what are the drawbacks of this RCNN? The training is too expensive in terms of space and time. Here, what will happen with the very deep networks such as VGG16? They use VGG, the basic version of this RCNN use VGG16. This process takes 2.5 GPU days for 5K images of walk 7, walk 2000, Pascal walk 2007 train and validation set. And object detection is quite slow. At test time, features are extracted from each object proposal in each test image. So detection is VGG16 takes this much seconds on GPU. Next is the faster RCNN. So the input image is there. Then you have convolution neural network, convo5. Then it will now whole image is passed to this convolution neural network. And this after that, the regions of the interest from the proposed identified from this using this neural network, and then ROI pooling layer will be there. Then after fully connected layers are available, and it will, that is softmax classifier will be used after that, and linear softmax and the linear there. Now, the next version of the fast RCN is the faster RCNN. The modification is that again whole image is passed to CNN. Here we have feature map, and that again that given as an input to region proposal network, and as well as the ROI. And then proposals will be classified. It will calculate the classification laws and bounding box regression laws, and then after classification laws and bounding box regression laws. And so again, output of all these algorithms will be the.
Sorry for the interruption, dear author. Actually, we are running out of time, so please conclude fast.
Okay, madam. So I'll just show you directly the thing that I implemented, and I'll quickly show the that fine. Just one. So next is YOLO and single shot detector. These are some evaluation parameters for object detection is there. Mainly all the standard parameters that for object detection is mean average precision. Right now, I do not discuss right now this. I just skip this augmentation detail that I used. That I'll let you know. Okay. Now, normally I'm just using the algorithm steps. In my algorithm, what I do, I use the normally generate. I will use that. First, I convert my images to divide into train and test set, and then I applied. I will generate a label map and train and test records, and load that pre-trained model and its weight, and then change the necessary parameters and feed the input to the path model. Apply transfer learning on open image data set, and explore newly trained model and test the model, and optimize and reset the model for better performance. And I calculated the MAP, right? Mean average precision. This is the actually my experiment. So the total number of images is 2000. In that training image is 1800 and testing image is 200. Then after the ratio of train and test I divide, that is 90-10. And I work with a 3 object category: bicycle, bus, and car. And I use number of steps 10,000. And right now I'm here I use SST 101, SST mobile link, and faster I have CNN with that is ResNet 101. My input image size is 640 by 640, and these are my results. I just show you in comparison. So actually, I also apply augmentation on images that I do not represent the same thing in paper, but I get this results. That is MAP in case of mean average precision without image with image augmentation. I get this much results, and these are the comparison graph of my image. So basically, I'm just trying to do. These are the images available. Using this simple these are the simple output of my images that I get. Here I get all the objects detected. Like I see in this particular image, I also see this this car is partially viewed, so only front end of the bonnet is showing me. So here a car is given. Here only here again occlusion is available. Still it detects the car. Here I add these images to show the challenges that this object detection algorithm. See here this car is available, but the view is that is kind of watermarking image. Still they are detecting. Buses are there, right? So this can be the thing will be there. So this is this I just apply sample algorithms on my object on open image dataset. I work with only 3 objects right now, and I'm going to work with the more objects of this category of vehicle dataset in future. And I just want it should be give me the whenever I just apply more images, and so hopefully my results will be improved. So basically this algorithms are they are the pre-trained models, and they use the different base network is just as ResNet 101 having 101 layers. Right? Residual network, right? So these are the image sample images of output. So see some of the images having difficult to identify which object is far away.
Dear
So
author, I'm so sorry. Now the time is over. Now you have to stop the presentation and wait for the further question and answers by session chair.
so just I conclude that thing only. Okay, fine, no problem. Okay, continue with the questions. Hello.
Yes, Nirmal. One question. What are the results in case of overlapping objects?
Sorry?
In case of overlapping objects are overlapping to each other.
Okay.
Case, how it works?
Ma'am, first, normal, whenever objects are overlapping, in some of the cases it provides me the good result, but for all images, if I had already tried so many images, in one images, it is in that images, the only partial view of particular bus is available, and which is very little, and which is hidden by some another car and all that. In that case, it is difficult for this algorithm to detect. So I also found a solution that if I provide more training, there are some other solutions that if I increase the number of steps, in fact, I can provide more challenging images as a training. So it may be possible in that such cases, it will give the better comparatively perform better in such cases. So for some images, it provides me a very good output when object is partially viewed or hidden. But in some cases, it having issue.
Any other exceptions you found in the detection where it could not detect?
See, I also provide some images which is little bit blurry. So in such cases also, it is difficult for this algorithm to detect the object. And images little bit having more clear view.
Okay. Okay. Thank you, Niral.
Okay. Thank you.
Yes, thank you so much, dear author. Now let's move further. Please, can you please stop sharing the screen so I can share my screen?
Yeah, just 1 minute. Actually, I have. Is it fine?
I would like to call our next presenter to present her paper on advanced steganography key pairing. Do we have the presenter?
Yeah, I'm here.
Okay, please continue.
Okay. Hold for a minute. Share my presentation.
If it is not possible, ma'am, then you can share your presentation or PPT with the conference team, so we can share on behalf of you. But meanwhile, we are moving forward to next presentation. Meanwhile, you can share your PPT with us. So we are moving forward to the next presentation, that is to present her paper. Do we have the author, Ms. Rashmi? Okay, the next one is Jyoti Mante to present her paper on attack detection in Internet of Things, a systematic literature review.
Yes, madam, I am there.
Yes, please continue with your
Yeah,
presentation.
yeah. My screen is visible?
Yes, ma'am.
Yeah. Very good afternoon to dear all. Myself Jyoti Mante. I am research scholar at School of Computer Engineering and Technology at Dr. Vishwanath Karad, MIT World Peace University. Today I am going to give a presentation on attack detection in Internet of Things, a systematic literature review. The outline of today's presentation is introduction, DDoS attack taxonomy, then intrusion detection systems used for intrusion attack detection, literature survey for different types of machine learning and deep learning approaches, feature extraction and feature selection methods used, data sets used, and what are the key challenges that I have identified after doing the literature survey, conclusion and references. Starting with the introduction. So basically the IoT market is growing at an exponential rate and it is been expected by 2027 that 75 billions of IoT devices will get installed. As IoT is giving services, giving wide range of services in different domains. So, because IoT devices generates a large amount of sensor data. So that data requires authentication, security, and privacy. And therefore, the security of such complex network infrastructure is a challenging issue. And cyber security attacks comes here into the focus. Cyber security attacks have increased rapidly in various domains of IoT sectors like smart homes, healthcare, energy, agriculture, automation, and so on. So previously, to mitigate these cyber security attacks, traditional methods and frameworks were used to ensure the security of IoT, but they are not helpful in IoT environment because IoT consists of an heterogeneous network. Different devices are there having less computational power, less memory. So these traditional methods are not helpful to provide security to this IoT environment. So artificial intelligence is considered as one of the most promising method for addressing cyber security threats and providing security. Uh, uh, Basically, different computing paradigms are used for giving different types of services to the users. So cloud is one of that, but remote cloud suffers from scalability of handling massive data analytics as it is a centralized repository. So there are a problem of a failure of this centralized repository. So to avoid this, the cloud services are extended to IoT devices through fog. As you can see in the diagram here, fog node, that is fog computing, has been introduced by Cisco in 2014 for time sensitive data. And this data directly going to the cloud. Whatever data the sensors generates, that are first processed to the fog node. Some processing is done at fog level and then it is furtherly processed to the cloud level. So basically this fog computing is used to reduce the latency, to save the bandwidth as well as to save the storage of the cloud. But this previously cloud was having a security threat. As fog has been introduced, fog computing concept has been introduced. So there are problems related to this fog computing also regarding security issues. And as per the Cisco report, there will be among different types of attacks that happens in the IoT. Distributed denial of service attack is one of the most vulnerability that has been addressed. 30%, 37% of the attack are denial of service attack. This is the report given by Cisco, and it has been expected that by 2023, near about 15.4 billions of DDoS attacks will happen. One of the example here I have listed is Mirai botnet attack that has happened in 2016. It is one of the largest distributed denial of service attack that has ever happened, and it has took down GitHub, Twitter, Netflix, Airbnb, etc. different types of sites. For many years, the quality of service was being affected due to this denial of service attack. This is one simple scenario that I have given here in IoT. So attacker uses different handlers to create a zombie network, and this zombie network is used to attack this victim to disrupt the service of this victim and to affect the quality of service. So this is general scenario for DDoS attack. DDoS taxonomy. So basically DDoS attacks can be classified into different types. As per the F5 lab report, 73% of DDoS attacks are volumetric DDoS attacks, out of which 53% are reflection based attacks launched using vulnerable servers or infected devices. So based on these, DDoS attacks can be classified into reflection attack or an exploitation attack. So reflection attacks are nothing but here the attacker identity remains hidden, and it uses legitimate third-party components to disturb the service of the victim. So what they are doing, they are just jamming the service. The service is made unavailable to different users. So under reflection attacks, different types of TCP or UDP attacks here I have labeled. And exploitation attacks, they are similar to reflection based attack, only the difference is that they uses this exploitation attack is conducted through application layer protocol, HTTP, using transport layer protocol. So under this you can have different types of TCP attack and UDP attacks. Now to prevent or to detect and mitigate the attack, traditional intrusion detection systems are used. Based on architecture, they can be classified as centralized or distributed. And based on deployment, it can be classified as host-based or network-based, or combination of both, that is hybrid. Based on detection approach, for detection different types of intrusion, it can be classified as signature-based, that is the traditional one. Some predefined patterns are saved, and the incoming packets patterns are compared with the predefined signatures. NML based intrusion detection, this is now most commonly used. So it uses different machine learning model to detect the normal baseline, and based on that baseline it differentiate between the attack and non-attack pattern, and combination of both is hybrid. So in an IoT environment, intrusion detection system with the help of machine learning models are most familiar for detecting different types of attacks in IoT environment. So I have done a literature survey near about 60 to 70 papers I have referred. Based on the papers that I have referred here, I have segregated the number of papers that have used various machine learning and deep learning approaches. So the commonly used machine learning approaches are naive-based decision tree, random forest, support vector machine, out of which random forest has given good accuracy. Clustering KNN algorithm is also used. Then fuzzy C means logistic regression and artificial neural network are not much popular for detecting attack in IoT. Deep learning models are used. So deep learning here consists of either deep neural network, recurrent neural network, deep belief network, or multi-layer perceptron neural network. So different deep learning models are also being used. So based on the literature survey that I have done, this is the literature survey file that I can show to you. So based on this literature survey, I have identified some challenges that are some limitations of the existing machine learning and deep learning algorithms. With naive Bayes, the conditional independence of the assumption class results in less accuracy. With k nearest neighbor, as it is difficult to figure out what the best value for k is and how to find the missing node if some node is missing. With support vector machine, the use of optimal kernel function, which is utilized for separation of data that is not linearly separable is still a challenge. And some of the machine learning algorithms provide better results. They provide a better result, but with higher false positive rate. Then regarding existing deep learning models that have used, they require high training time. Basically, deep learning models are good for image data set. Normal attack data set doesn't contain any image data sets with it. So deep learning models require high training time and consume high computational power, and it requires expensive resources for deploying their models as compared to machine learning model. Also, deep learning and artificial neural network require extensive computing power for execution with multiple hidden layers, as it consists of different hidden layers. And these techniques give better result, but it utilizes maximum resources to establish that hidden layers and hidden units. And as we go on increasing the hidden layers for increasing the accuracy or to overtrain the system, the result we get will be optimum, but there will be a problem of overfitting issues. So most of the proposed approaches that I have studied, they have been evaluated using offline analysis on benchmark data set, and therefore the performance metric values could change in the production or real environment. And different feature extraction and selection techniques that I have gone through. So basically features extraction is used for normalization and dimensionality reduction, and feature selection, it is used to find out the best features to remove the redundant one, so that it can lead to faster and better classification model. So the feature selection methodologies basically are supervised and unsupervised, and then supervised are classified into 3 groups: filter, wrapper, and embedded. So with filter approach, no machine algorithm, no learning techniques are used. So computationally, they are not costly and have strong generalization due to their independence from training algorithm. Only the limitation is that the right subset of features may not be selected if the criteria used differs from the criteria used for learning during training phase. With wrapper approach, it uses different machine learning algorithms to test different set of features and evaluate their accuracy. They give a better accuracy by selecting good features. But if feature set is very large, then this approach becomes computationally expensive. And last one is the embedded approach. Embedded technique consists of benefits of both filter and wrapper based techniques. So whatever literature survey I have done, based on that, this is the common graph that I have used for feature extraction and feature selection techniques. So normalization, then principal component analysis and linear discriminant analysis, autoencoders and filtering techniques. They have these 3 are used for feature extraction technique, among which normalization, min-max normalization or z-score normalization has been mostly preferred. PCA, it can be used for feature extraction as well as classification also. Regarding autoencoder, either one hot encoding or label encoding has been used, but they have some disadvantages of their own. Then here filter method I have listed out because the authors has not given any specific name for the filter methods they have used. But most of the, as you can see from the graph, most of the authors have gone for filter method rather than wrapper or embedded one. So based on the literature study of feature extraction and selection, the most common pre-processing strategy used was for feature extraction and dimension reduction was min-max normalization, principal component analysis, and autoencoding. And the most common method used for feature selection is filter method. Either the authors have used gain ratio, mutual information, correlation coefficient, chi-square, etc. So due to many IoT network traffic features, as
Dear
IoT,
author, now you have to conclude your presentation as we are running out of time.
just
and I
tell me.
request each and every author to please strictly follow the timeline.
Yes, sure, madam.
Yes.
Yeah. These are the benchmark data sets that I have, whatever survey I have done. So authors have used different types of data sets. So here you can see NSL KDD is mostly used, and then KDD Cup 99, but both of them are not IoT based data set. Some IoT based data sets came into existence from 2019, like what IoT DS2S, IoT 23, or CIC IDS 2018, but they are not having enough amount of classes for differentiation of legitimate or attack traffic. And some authors have gone for simulated data of their own. Regarding data set, lack of proper IoT data set is there. Whatever data sets are available, they all are imbalanced data set, and lack of comprehensive data set, that is data set with all traffics like low rate, high rate, and flash traffic are also missing. So there is a scope to work on different feature extraction selection techniques as well as different types of data sets. User can create their own data sets for the future use. So these are the key challenges that I have identified. Selecting a good feature selection approach is actually required for DDoS attack detection. lightweight approach in IoT environment, it is must to distinguish between anomalous and anomalous activities. Then that will give a low false positive rate. That is a challenge. Then there is difficult to identify a suitable data set for a DDoS attack traffic. Whatever current data sets are available, they are either old or do not include sufficient data patterns to learn from the common attack features. Then evaluating the performance using actual IoT based data set that reflects the real world IoT cyber attack is also challenging. And whatever methods that I have studied, where all are investigating the attacks after they have already taken place and caused damage to the system. So there should be a mechanism to that should be capable of detecting DDoS attack at early stage to prevent attackers from accessing services, as it is a crucial part of any defense system. So concluding to this, this was my literature survey for the seminar that covers wide variety of ML and DL approaches. And there is challenge to properly detect the attack in heterogeneous environment of IoT using proper classifier. Also, according to the challenge identified during literature survey, some ML approaches gives high false positive rate, which is not acceptable, while DL approaches are computationally costly and complex. So false positive rate and false negative rate is still in doubt. So there is scope in improvement at this point, and combination of extraction and classification gives different accuracy. So according to the challenges, whatever I have identified, there is scope for improvement in this process also for feature extraction and selection. These are references I have referred. Thank you.
Yes, Jyoti, one question. Quickly, we'll take one question only.
Yes.
Detecting this at the early stage, or maybe for prevention.
Yeah.
What would be the best method you say?
Whatever paper I have referred, madam, they are either using ML or DL approaches. So I have gone through one of the paper, need of reinforcement learning in IoT security. So my work will be focusing on making the smart intelligent system for early detection of attacks using reinforcement learning. So I will try using that. I have came across a paper where there it has been said that reinforcement learning is needed for IoT security for detecting attacks at early stage. So reinforcement learning, it works like a human brain. Whatever is present in the environment, by looking after the environment, the brain takes the decision. So based on that.
Okay. Okay, Jyoti. Thank you.
Thank you so much, dear author.
Thank you. Thank you.
Now the next presenter is Priya to present her paper on identification of political hate speech using machine learning based text toxicity analysis. Do we have Priya?
Yes, ma'am, I'm here. Am I audible, ma'am?
Yes, ma'am. Yes, please continue.
Okay. Ma'am, is my screen visible?
Yes, yes, please continue.
Okay, thank you. Good afternoon to everyone. My topic of presentation is identification of political hate speech using machine learning based text toxicity analysis. These are the contents of the presentation: abstract, introduction, literature survey, objectives, research methodologies, overview of technologies, conclusion and future scope, then references. So abstract, hate speech nowadays is a very crucial problem. Hate speech is becoming a problem today, as we consider internet as one of the leading factor for the prevalence of hate speech. With the advent of time, as a usage for internet is increased, people uses this platform from different origin, caste, religion around the world for expressing their views, especially via social media like Facebook, Twitter, Reddit, YouTube, etc. So social media basically plays a very vital role, and hence hate speech is referred to as hurting someone's emotions or a group of people on the basis of their caste, color, creed, nation of origin. The maintaining of civility thus becomes very difficult at times, especially when it comes to electoral gains by some of the political parties. In this study, contemporary data from Twitter is used for identification of hate speech with help of machine learning algorithms using natural language processing techniques. And we took in consideration the tweets from some political parties or person of political parties for analysis. Introduction. Hate speech has already, as we have already defined, hate speech is basically an agitation to hatred, predominantly against a group of people or an individual. So for social, social media acts as a turbo accelerator for hate speech. So some standards have been defined by the European Union agencies for controlling this controlling the text of online social media community, that basically defines if anything that basically defines hate speech is classified as a text that hurts someone's emotions and attacks on the ethnicity, caste, creed, religion and disability of someone. So one should be very much controlled, regulated and composed while expressing his or her thoughts and also respect someone's emotions. This is the literature survey that has been done. These were the papers that were undergone. Basically, this paper considers the specifically focus on the hate speech analysis with respect to political context. As initially, when this work was started, there was no such contribution made by some authors or research scholars for political hate speech. So these are the objectives: mining of social media for collection of available political speeches in Indian context. And here the social media that has been used is Twitter. Creation of data set of labeled data of hate speech, and then designing a machine learning algorithm to classify text as hate or non-hate. This is data analysis phase. Basically, as per our requirement, first of all, we need to collect the data. Then data pre-processing is being done. Pre-processing consists of data extraction, cleaning, transformation, and loading. Afterwards, with the help of any suitable technique, we can analyze that data. And then communication means data visualization in terms of any bar graph, any charts, pie chart, or word cloud. This is the research methodology that has been used over here. Data collection is done from various available sources. Real-time data from Twitter has been collected in this work. Then data pre-processing, then POS checking, text classification, and visualization. So this part, data pre-processing and POS checking, is defined over here. First of all, data in the raw text form, that is in form of string, is collected. The string, that is basically complete string sentence, is broken up into tokens. Then tokens are stamped and lemmatized to its base library. Then POS tagging is being done, like in a particular sentence, which word belongs to which part of sentence. POS means part of speech tagging, like what is verb, what is noun, what is adjective. And then entity relationship detection is being done. This is the data set. This is a snapshot of a data set that has been collected from Twitter. And the methodology used for collection of data from Twitter and then its implementation. So basically this diagram represents first of all, when we want to collect data from any social media, user need to request for authentication for his or her request from Twitter. Twitter API provides access after user authorization is approved and ask for the reason for data collection. Then if everything goes well, a token is being generated after a span of 72 hours, and then token remains active for 24 hours. Meanwhile, in that particular duration, in a duration of 24 hours, user can collect the amount of data. Afterwards, that token is deactivated. Again, if much more data is to be acquired, to be collected, then again same process need to be followed, but user ID and password for the user remains same. This is basically the methodology. Data is collected from Twitter. Data is annotated, then cleaning, lemmatization, and lowercase means data is being pre-processed. After pre-processing, feature extraction is being done. Feature extraction is done on the basis of, like, when we collect data, data comes with number of features. Like in a table, if we are having a table for a student, there is roll number, name, father's name, mother's name, address, phone number. So out of that, we need to extract the features that on basis of which part of that dimensions we want to analyze our data. So we can just remove the unwanted features from that. And then classification is being done using the suitable machine learning algorithms. Like here, it shows support vector machine, SVM are random forest, Navis, and extreme gradient boost algorithm. Then models are evaluated and final analysis is being done. These are the result of models that I have used in this work: support vector machines, random forest, logistic regression, and XGBoost.
Ma'am, I think time is over now, so please
Yes, ma'am.
continue your presentation.
Yes, ma'am. And this is the data visualization after implementation. This is the word cloud that has been formed. Technology is being used. AI is a broad area, machine learning, and then in machine learning, I have used NLP. This is a conclusion of my work, that machine learning techniques provide insightful methods using NLP that allows for the identification of hated and non-hated text. The result indicate that using an English corpus with analytical library allows 98% of accuracy for the prediction of text. However, this could be improved with more corpus and using multilingual hate speech identification models. These are the references. Thank you, ma'am. Ma'am, am I audible?
Yes, dear author, you are audible.
Okay, ma'am.
Yep, yeah. Thanks for the presentation. Can you just tell me, I mean, what would be the exceptions in this detection?
Ma'am, right now that I have one challenge that I have faced is these algorithms are working for the English corpus. Like if some user is posting some comment, like using with a combination of Hindi plus English plus and with some smiley. So my text is right now detecting only the English text. It is not working right now for the multilingual, like for Hindi or some smiley, some emoji, whether this emoji is using a hate speech or a non-hate speech. So that till now, that is my future scope, that in future I would be working for that.
Okay, thank you, Priya.
Okay, thank you so much, ma'am.
Okay, now the last presentation we are going to have is of Nidhi Bansal on advanced stenography key pairing. Nidhi Bansal, we are having.
Yeah, I'm here. Can you share my-
Yes. Just wait a minute. I am sharing your PPT, and
Okay.
I am requesting you to please be on your timeline.
Yeah, I'll complete it in 2 minutes.
Please start your presentation.
Okay, hello everyone. My paper is based on advanced steganography, that is subtitle is key pairing. In this paper, we have introduced a technology to hide the data. As we all know about the steganography, that is the concept to hide the data or original message, we can say. So rather to secure a single data, we have applied a technique to save a single data into multiple images, multiple 3 images. That is multi-tech technique, we can say. Means rather to cover a single text with a single covering letter or envelope or secure technique, we have combined 3 envelopes into a single original message, or we have covered a single text message with the three covering images, or we can say secure images. We have applied encryption algorithms to secure that data, and we have designed these envelopes by using keys and encryption algorithms. So this is the basic new technology we have introduced in our paper. So you can see in the images. Can I go on that slide, please? You can see a single text data we have, and I have covered these single text data with three images. Can I move on that image, please? Yeah, you can scroll it down. Yeah, this is the image only. You can see this is the single text message or whatever. As due to there are many forgerers are there as the world become a digital world now. So this is the single text I'm showing here, and I have designed three envelope or encryption envelope. You can say encryption images. I have applied. I have split this message into three parts. So this is the significance only that if any attacker is comes into my message or to attack to my message, so the he has to recover three images. So this is a very tedious task because they will try only for one cover or one encryption or decryption algorithm, or that will try for one chance or two chance maybe. So there he has to attempt for three chances to recover the original message. So this is the original. This is the advanced concept we have introduced in this paper. This is the only significance of our paper, and this we have implemented in MATLAB. You can show the results in the downside of my slides. There are MATLAB implementation. In that we have used 126 pair of secret keys and 117 pair of private keys to unlock the original message from the receiver end to sender end back. If they want to decrypt the message, you can see to decrypt the message, we all these three images, we have to all decrypt these three images. So if we do not have any one party, so with the two images only, we cannot decrypt the message. So this is the higher security we have applied in this. So now this is overall about my paper, or you can ask the questions, please. Pratik Singh sir is here for answers the question. Please, any query if you have.
So, I mean, what is the significance of this study?
Pratiksha, are you there?
Hello? Is it,
Okay, Pratiksha, I think he's not there. The significance of this paper is only there are multi-level encryption is there. So this is very tough to recover all the three images for a single image. So that's we have introduced this technology.
okay, Nidhi, thank you.
Thank you.
Thank you so much to our all authors. I sincerely thank our all authors for their excellent presentation and great contribution to this session, and all the participants for being part of this international conference. I hope this session was informative enough. On behalf of the whole team, thank you so much for your support in this version of the conference, even in the previous 6th version of the conference, and we will be happy to have you in 8th version in 2023. All the participants would be getting their digital certificates within 2 to 3 working days. Papers have already been submitted to the Springer, and publication will be live within 5 to 6 months. So kindly cooperate with the team ICT4SD 2022. I also would like to thank our session chair, Dr. Swati Nikam, for chairing the session. Ma'am, here is a token of appreciation for you. Just a minute. Ma'am, thank you so much for your support and valuable presence in this session. Thank you so much, ma'am.
Thank you, Prathna. Thank you, all the participants.
Yes, now I would like to request all the participants to quickly turn on their camera for a quick snapshot and good memory of this session. I request all to turn on their camera so I can take a good memory and a snapshot for a good a glimpse of this. Okay, thank you so much, everyone.